Deleting values from a binary search tree. Case 3. The node we want to delete has two children. Suppose I want to delete node 28. As you can see, node 28 has two children. So what I'm going to do first is look for the in-order successor. What is the in-order successor? It is the node that, if we were to do an in-order traversal, would come directly after 28. So how do we find this node? Well, one way to do it would be to do an in-order traversal and see which node you would visit after the 28. Another way would be just to look at the right subtree of 28 and look for the smallest node in that subtree. Now, how do we find the smallest node in a tree? By simply going as far to the left as we possibly can. In this case, that node is 33. So, now that we have found the in-order successor, the next step is to swap the in-order successor with the node we want to delete. We're going to swap the values. And what this does is that it takes us out of case 3 and brings us to either case 1 or case 2. Why? Because 28 now will either have no children or it'll have one child. In this case, 28 now has no children, so we simply delete the node and the deletion is over. But now let's rewind it back. Suppose 33 had a child. Well, we would still swap 33 and 28. The only difference now is that instead of going from case 3 to case 1, we're going from case 3 to case 2 because 28 now has one child instead of no children. So, in order to delete 28, we're going to bring that child up to take its place, and that completes the deletion.